Good morning. Hello, everybody. Welcome to Monday's math class. Good morning, Cass. How is everyone doing this morning? Bright and early. Love that you guys are here, ready to go. Hope you guys got lots of sleep on the weekend. So tell me about it. Tell me some fun things that you guys did on the weekend. How did everything go? It was my husband and our 10 years married anniversary on Friday, so that was kind of nice. And then Saturday we had a housewarming party because everything's done except our countertops are coming in on Thursday, so it's a week late, but that's okay. So we had that, and then I decorated on Sunday, and then I did report cards for my grade 8 kids. So it was a busy weekend, but it was fun. You got heat stroke. Oh, Jocelyn, that's not good. That gives you a nasty headache when you have that sometimes. Yeah, it does do that, doesn't it? Do I have a daughter? No, I don't. No, I'm just weird because of my own normal self. Yeah. I like all the juvenile stuff because I'm a child myself. So yeah, I have no child to blame it on but me. So yeah, cool. Anyone else besides getting heat stroke, Jocelyn? Anyone else do anything spectacular? Welcome. Got a couple people joining us here. You worked 8 hours on Saturday, and then I put my tree up. Nice. Great. Are you liking your job, Caitlin? Hope that's good. Oh, yay, Belle made it. That's awesome. Got a few more people here. Good. Okay. All right. So, and nothing else to share. Nothing else going on. We had someone working. We have someone with heat stroke. It makes a huge difference when you work with people that are really good. That's awesome. That's why I love working here. It's so fun. Oh, you got a puppy. You got to send me a picture of the puppy. Oh, yeah. What kind of puppy? That's so cute. What'd you get? She's typing lots. Yeah, I was going to ask you about how did that go? Yeah, did it go okay? Your mom sent a message that there was some tech issues or something like that, so hopefully everything was able to work out properly for when you needed it. So it's always fun when that happens. Oh, that's awesome. That's really cool. That's a smart dog. They're so cute as puppies too, if I'm remembering correctly. They're so adorable. Well, what puppy isn't cute? Like seriously, they're all cute. That's good. Awesome sauce. Okay. So today we are looking at, that should say December. It still says November. You can tell I'm still stuck. Yeah, all good. So volunteering food bank on Tuesday, archery lessons for group 2. So group 1 you're not on till next week. So group 2 is on this Friday and then next week as well. Okay. So we're just going to look to see if there's any questions from last day's work. We're going to do a little more learning again. Practice worksheet, 1 to hand in. It will be so much fun. Okay, so let's have a peeky poo. Anyone have questions from the practice worksheets from lesson 1 and 2 or anything that you guys want me to go over? Let me know. Yeah, so Belle, I saw your message. Your mom sent me a message, so we're good. Yeah, I replied to her this morning, so we're good there. So any questions, guys? Probably, I have only a few of you guys handing stuff in, so guys, whatever we're doing, we're going to have to like pump it up a notch. You guys should be doing a minimum of 5 hours of work a day on school. Trying to keep up with basically what they do in regular school, and I think some of you guys are just attending classes and not doing a ton afterwards, so, or you just need to make sure you get things completed and handed them in. So I'm a little concerned about some of you because we're 2 units in and some people are behind on those, and then this is the 3rd unit now that I got to get people caught up since we started for term 2, so we need to get going there. Okay. So, since there are no questions, I am just going to bounce around here. Okay, So we're going to start looking, so we're talking about the slope, y-intercept, and everything that, how things cross the line, and looking at how things are plotted on a graph and how we can do that. So what we're going to do is now we're going to take it up a notch. And we are going to start looking at, a little bit more specifically, looking at some formulas for doing this. So if you can, it would probably be useful. Obviously, I keep telling you have those blank graphs available or graph paper available. Just quickly plot these 4 points down and then just draw a line going through. And I want you guys to notice that despite having put a couple dots on those spots, you guys notice the line just keeps going. So try to avoid just going dot, dot. Sorry, I'll make it bigger. Dot, dot, and then just doing something like this. Try to make it look a little longer than that. Or plot a couple points versus just 2, and kind of draw it a little bit longer. So, okay. So what I want you to do is I want you to look at those 2 lines, and I want you to tell me what the slope of each one of those lines are. So that's going back to looking at slope, the formula for a slope. So if you guys remember correctly, I'm just going to erase my little stuff there. It is m equals y2 minus y1 over x2 minus x1. Okay, so you can use that formula. What's the other way that you can do it? Because we have an actual graph here. So I can use this formula if I didn't have a graph, or if I wanted to use the formula. What's the other way I could do this question? What would be the other way I can find the slope of these lines on the graph? What would be the other thing I could do? What else can I do to find the slope? I'm not giving this to you. Count what, Dean? Yep, but I need to find out what slope is before I can do, yeah, I could, oh, I see what you mean. Bryn, do you mean like plug everything in and find m? Yep, that's another way. And do rise over run, yeah. So we could do a couple different things for this one. So because we do have the graph here, and I have the points written down, all we have to do is put it in the formula, or we can count. So we got 1, 2, 3, 4, 5, 6. We have 6 over 1, 2, 3, 4. So this is going to be, this is line 1. They have that little line 1, line 2. So if I do line 1, okay, and the problem with that is that it's not reduced. So if I reduce that, I get 3 over 2. Then if I look at this one, I have, where are my 2 dots? There we go. 1, 2, 3. So line 2 is 3 over 1, 2. So what do you guys notice about the slopes of the lines? What do you notice about the slopes of the lines? That's a 2. They are the same. So what kind of lines are they? If they're both the same line and they're going the same slope exactly, these are parallel lines. So parallel lines have the same slope. Okay. So if the question is asked, are these lines parallel, all you have to do is find their slopes, and once you find their slope, you can determine if they're parallel or not. Okay. So that is the first piece of information I wanted to tell you. Okay. All right. So what we're going to do now is we're going to look at an equation, and I'm not going to give the graph this time. All right, so a lot of times the graph is nice and easy. We just do a count, figure it out. So now this time you're going to actually use the slope formula, which is this one at the top here, and use that formula to find the answer. Okay, so I want to know if these two are parallel. Okay, so I have 4x minus 5y plus 15 equals 0. And the other one is 8x minus 10y plus 30 equals 0. Okay, so what I want to do, what I want you guys to do is I want you to, what I would suggest doing is taking this and putting it into slope-intercept form. So I'll show you this one and then I'll get you to do the next one, just as a little reminder here. So this one we want to get it into y equals mx plus b, and I can't remember who said that, or Bryn did. So that's slope-intercept form, and when you put it that way, very easy to see the slope because it's m. It's right in front. So what we're going to do with this is called general form, and we're going to take it from general form and put it into slope-intercept form. Okay? So what I want to do is have y on one side and all the stuff on the other side and no number in front of y, just a 1. So here's what I would do with this. I have two options. I could keep the y on this side, so keep this guy here and move the 4x and the 15 over, so I'd have to do two movements, and I could do it that way, or I just move the y over and work on it that way. It doesn't matter what you do, whatever makes more sense to you. I'm just going to show it the way probably most of you guys would do. So if this is positive 4x, I'm going to subtract 4x from both sides, okay, and you end up getting negative 5y plus 15 equals negative 4x. Okay, so all I did was move over the 4x because I'm trying to get the y by itself. Then all I'm going to do here is get rid of the 15, so I got to subtract 15 on both sides. And again, the point of that is to make that disappear, so I'm left with negative 5y equals negative 4x minus 15. I cannot combine them because they're not like terms. Okay, and then now I'm pretty much in the form I want to be, except I do have a number other than 1 in front of the y, so I have to get rid of it. So the negative 5 and the y are multiplying to each other, so I got to divide by 5, and I have to do that to all the numbers on this side. Okay, I have to divide what I do to one side, I have to do to the other, and I have to do to everything on that side. So when I'm all said and done, I'm left with y equals these guys. The two negatives, negative divided by negative is a positive, so I don't have to worry about the negatives. That's going to stay 405, rise over run. I have my x, and then I have a negative and a negative, so it's positive, and 15 divided by 5 is 3. So what I just did there was took it from the general form, made it into slope-intercept form, and now I can see what the slope is of this line. So there's the slope of this line. So what I need to do in the other formula, other equation, I need to now figure out what the slope of that one is, and then I'll be able to tell if these lines are parallel or not. So I'm going to give you guys 1 minute to complete the other one and see if you can turn it into that. Okay, so 1 minute, go ahead guys. Okay, so now this one, same idea. I'm going to just do the process here for you. So what I'm going to do on this one is I'm now going to move the y over instead, so I don't have to do two movements. I'm just going to do one. So just watch what I do here. So I'm going to add 10y onto both sides. Okay, so this disappears, so I'm left with 8x equal, oopsies, sorry, 8x plus 30 equals 10y. So now I'm at the same form. It doesn't matter if it says y equals 6 or 6 equals y, same kind of thing. but I still need to get rid of this. Those two are multiplying together, so I'd have to divide 10 into each one of those. So when I do that, and I have to reduce, so I end up having 8 over 10. I'm just going to leave it as 8 over 10. Someone tell me what's wrong with that, and what's wrong with 30 over 10. What is wrong with those right now? Why don't I want to keep them like that? What do I need to do? Yeah, I need to reduce them. Simplify, they're not simplified. Good job, guys. So I'm going to reduce these. I'm going to divide this by 2. So I end up getting 4 over 5, x. And what I can do now is I can just move this over so it looks more like what you're used to if you guys want to do that. And then 30 divided by 10 is 3. So are these lines parallel or not parallel? What are they? Good. They are parallel lines. So you guys are now able to tell without actually seeing a graph, without actually plotting it on the graph, you guys are able to tell if this line is parallel or not. So that's really cool. Good job, guys. Fantastic. So now what we're going to do, I'm going to move on. Are we good? Has everyone got that written down? So now what we're going to do is we're going to look at perpendicular lines. And if you remember, perpendicular lines is when they, oops, that's sorry, not in my pen mode. They cross at 90 degrees. So it's pretty much what's happening right there. Two lines cross and they form 90 degrees. So that's a perpendicular line. Thanks, Kaylin. Glad you made it. Okay, so now we're going to look at perpendicular lines. And so parallel lines, the slopes have to be exactly the same. The slope goes up by ones, this goes up by ones. As soon as you change that, eventually, it could be like way down the line. Eventually, they're going to cross if they're not the same slope. So this one, perpendicular, they are going to cross, but we want to make sure that they're crossing at 90 degrees. Okay, you'll have to just, I guess, Kaylin, you'll just have to obviously watch the recording after class, so you can hear us, and if you know the answer and not be able to see it, you can do that too. Okay, so with this, we're going to look at the slope of this guy. So I'm going to look at the slope here of this line, line 1. So line 1, I'm just going to kind of make it look like an L a little bit. So I'm going to go down 1, 2, 3, 4, 5, 6. And 1, 2, 3, 4. So 6 over 4. So line 1, if I reduce that, divide by 2, I get 3 over 2. Okay, so I think that's the exact same line as it was on the other one. But now we have another one. Now we have a different line because we're trying to make perpendicular. So I'm going to count, and this is a negative slope because it's going this direction. Because it's going that direction, it's a negative slope, so I'm going to put a negative in the front right away. Excuse me. So 1, 2, 3, 4, 5, 6, 7, 8. So that is 8 over, and where am I? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 8 over 12. And then if I reduce that, I can divide by 4. So I get negative 3, oh, sorry, negative 2 over 3. Okay? So I want you to look at those slopes right now. So this one is 3 over 2, and this is negative 2 over 3. Can someone tell me what are some things you're noticing about the two slopes? Because we are working with perpendicular lines. So there is going to be sort of like a general rule for out of this, just like we did with parallel lines, same slope. There's going to be something coordinated between these two. What are you guys noticing about the slopes of perpendicular lines? Because we know these are perpendicular and just showing you what they are. So what, yeah. Thank you for jumping right to it. I was hoping to like work our way there. That's awesome. Thanks, Jocelyn. So it's called negative, they're opposite, exactly. So negative reciprocals is the exact wording I'm looking for. So I'm going to write it down and then I'm going to explain to you what it is. Negative reciprocals. Try to remember how to spell it. There we go. Okay. Negative reciprocals. So I will show you what I mean. So what this means by the negative, meaning it's going to be opposite signs is what it's talking about. It doesn't mean the answer has to be negative, but it means that if I multiply by negative, it gets me the opposite. So I'm going to kind of show you what I mean. So let's say my slope over here was 1 over 4. If I times this by a negative, my answer is negative because this is a positive. Okay? If this was a negative 1 over 4 and I times it by a negative, my answer is positive. So basically what it's saying here is that when you times it by a negative, what you end up doing is turning it into the opposite of it. Okay? So here, right now, this is a positive 3 over 2. The answer of the reciprocal of a perpendicular line slope is going to be the opposite of positive, which is negative. Okay? So does everyone understand that? So whatever the sign is of the one slope, to be a perpendicular, it has to be the opposite sign. Okay? If you want to remember your timesing by negative, you can. If you don't, doesn't matter to me, as long as you remember it's the opposite sign. And then look at the numbers. So this one is 3 over 2, and this is 2 over 3, and that's what kind of the reciprocal means. It means kind of the flipped version of it. So this one over here, if I had 1 over 4, what would the reciprocal of that be? So we know the answer is going to be negative because it's originally positive. So what's it going to be if I did the reciprocal of it? Yeah, it would be technically 4 over 1, which is the technical right answer. We would never write that. We would just say negative 4. That's all we would do. So that is the relationship of the lines that are perpendicular. The slope is going to be opposite sign, and then you flip it. Okay? So if it's already a fraction, it's kind of easy, because if it's 3 over 2, it means it's 2 over 3. But if it's 4, if it's something like this, you have to remember there is that 1 underneath it. So when you do flip it, the 1 does go on the top. Okay? So is everyone okay with that one? Good. Thanks, Cass. Okay. All right. Good, good. Okay. So this is what I want you to do. I'm going to give you guys a few minutes to do this. It's not going to take you too long. You're going to do 1A and B. And what I want you to do with 1A and B, I want you to find the slope that is parallel and perpendicular. So this one is easier because it's already in slope intercept form. So you can see the slope right away. So all you have to do is say what a parallel slope to that would be and what a perpendicular slope to that would be. B is in the general form. You're going to have to convert it into this one. So you're going to have to make it look like that, and then you just tell me what the slope would have to be. And this one, I want you to look at these ones here. There's 2 equations there, and I want you to tell me, are they parallel, are they perpendicular, or are they neither? Okay? So I'm going to give you guys, let's say 5 minutes. I'll give you guys 5 minutes. And I want you to complete those questions letting me know A and B, if they are, what the perpendicular slope is, what a parallel slope is to those lines, and then 2, which one is it, or neither. Okay? All right, so 5 minutes. I'll see you guys in a bit. Okay, so for the first one, because it is in slope-intercept form already, it's really super easy. You look at the m, which is -3, and if it's parallel, it's -3. So that one's nice and easy. And if we're doing the perpendicular, it has to be the opposite sign, so it's going to be positive. If you want, you write positive, you don't have to. I'm just doing that so you know. And then I take the number and I flip it. So right now, it is technically 3/1, so when I flip it, do the reciprocal of it, it's 1/3. So hopefully you guys did pretty good with that. Okay, and then this one, we need to change over. So I'm not going to stress about changing this one over. I'm just going to give you guys the answers to this one. Where are my answers? So the slope, the parallel slope is -7/5. And if we do the perpendicular slope, it's going to be opposite signs, so it's going to be positive. And then we're going to flip it over, so it's +5/7. So check mark if you now are like, oh, I see, I got it. You're doing pretty good so far. Okay. So if, Angelina, do you have a question? Or because an X means you don't see it now. So I'm assuming you're still not seeing how we did that. So what can I do to help you understand how that worked? Or some of you. So what is it that I can do to help you guys see how you got those things? Yeah, no, it's perfect. So as long as you kind of have an idea of what you're doing, that's great. Practice is always going to be needed, right? So, okay, so Angelina, the slope is always, when it's parallel, it's going to be the exact same. Okay, so it's going to be, if it's -3, it's -3. If it's -7/5, it's -7/5. The perpendicular one is whatever the sign is. So right now it's negative. Whatever the sign is, I make it the opposite. Okay? And then whatever the number is, I flip it over. So the number right now in this one was technically 3, means 3/1. So if I flip it, it now becomes 1/3. Okay? So we're going to do C together here. I'm going to actually show you, because the question is, does C, and I'm just going to erase, how did I get -5 though? Oh, you want, here, let me do that question then. Okay, so let me just, oopsies, I just got rid of the question. What was that? That was supposed to be negative, well, that's y. Okay, so if I actually do this question, I have to get the y on one side and everything else on the other. So I'm going to go, I keep the 7x here, I'm going to subtract the 5y on this side, subtract the 5y on this side, okay? And then when I do that, that cancels out. So I get 7x minus 5 equals -5y. Now I don't want the -5y, so I could divide by -5, and I have to divide everything by -5. Because what I do to one, I have to do to all of them. So when I do that, I'm gonna put my y back on the front. I get y equals -7/5x plus 1. Okay, so when I convert that equation into from general form to slope-intercept form, this is what I get. This is the slope. If it's a parallel line, it's the exact same slope. Okay, if it's a parallel line, it's the exact same slope. Okay. No, Belle. No, I got rid of this first. So I had to move this over. So when you're simplifying, so you guys remember BEDMAS? BEDMAS is how you expand something, okay? So it's an order of doing things. So if I 2x plus 1 minus 3 squared or something like that, I have to do, oh, let's not change that, let's make that. I have to do brackets first, then I do exponents, division, blah, 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 blah. That's how expansion works. That's how you make it bigger. You follow those steps. because I'm simplifying, because I'm trying to like make things move a little differently, I'm not having to do like making it bigger that way, you go the opposite direction. And I've mentioned this in previous lesson. We go the opposite direction. So you always do the subtracting first, then the adding, then, or whatever it is, it doesn't matter what order, and then you do that, go with that direction, okay? So, and then for this one, for perpendicular, opposite sign, so it's going to be positive now, and then I flip it. So it's over, whoopsies, I did two things at the same time. So this would be the perpendicular one, okay? So hopefully that helps, Angelina, for you to see what we did there. Okay? It doesn't matter, okay, so Angelina, it doesn't matter where the negative goes. I'm just going to show it on another slide here. I could have, this says the same thing. A lot of times, like I said, you're going to see the negative in the front. It's not going to be associated with the number. It's the same slope no matter where I put the negative number. So a lot of times you're going to see it out in the front. Okay, so hopefully that was good. Okay, so this one, I'm just going to erase this stuff here. And I'm going to show you with this question here. So we have 4x plus 3y equals 12. So I just need to get the y by itself. So I'm going to subtract my 4x from both sides. That goes away. So I get 3y equals negative 4x plus 12. I don't want the 3 there, so I have to divide everything by 3. So you get y equals negative 4 over 3x plus 4. Okay, so that, sorry, that didn't go all the way down. So that's the formula for that one. So this one here is negative 8x minus 6y equals 3. So I want to get rid of this guy, so I'm going to add 8x onto both sides. I get negative 6y equals 8x plus 3. Okay. Then I want to get rid of this, so I'm going to divide by negative 6. Have to do that to everything on the other side. So you end up on this side with y. I'm going to have 8 over negative 6, so what I'm going to do is just simplify it right now. I'm going to divide both by 2, so I get, and it's going to be a negative, so I'm going to put the negative out in front. So if I divide by 2, I get negative 4 over 3x. And this is going to be a negative because a positive and a negative, and it's going to be 1 over 3 because I'm going to simplify that as well. So you just need to make that a little bigger there. Thank you. So here are the slopes. There's that slope on this line and that slope on this line. Are they parallel, perpendicular, or neither? Parallel, perpendicular, or neither? Which one are they? Parallel, perpendicular, or neither? Just look at the slopes, guys. If they're parallel, they have the same slope. Perpendicular, it's the opposite sign and flipped over. And if it's neither one of those, it's neither. Okay, so the slopes are 100% identical. 100% identical. It's a negative, it's a negative. It's a 4, it's a 4, it's a 3, it's a 3. So they are parallel lines. Okay? So you see that, Caitlin T? Do you see how they are? It's all good. No, it's all good, as long as you can see that. Okay. So can I move on? Are we okay with that? All right. So what I'm going to do is we're just going to do a couple quick things, and then I'm going to get you guys to go off and do a little bit of work and then come back. Okay. So now what we're going to do is we're going to try to figure out when there's one part of all of this missing. We're going to try to figure out how to solve for that, how to find that missing variable that we don't know. So they gave us this information. They said M for line number 1. So that's a little subscript. We talked about that subscript, that 1. That just means that that's just a way of identifying what we're talking about. So the slope for the first line is 6, and then the slope of line number 2 is something. So we're using an A. Actually, no, I'm not going to use an A because that looks like a 9. You guys might get confused. I'm going to use a C. Is C over 7. So we know the slope is something over 7, and these lines are parallel. Okay? So these lines are parallel, so that means the slope of both these lines have to match, but we don't know what that one number is, so we got to work this out. So because they have to be exactly the same, we say this equals this, because this slope has to be the same as this slope, so we're going to get them to match. Okay? So is everyone with me on that one? Oh, good, Caitlin, good. Okay, so now we need to solve for C, all right? So all I'm going to do is C and 7 are dividing, so I'm going to get rid of that 7 because I want the C by itself. The variable needs to be isolated, wants to be by itself, so what I do to one side, I do to the other. So we get C equals 42. So right now I'm going, okay, C equals 42, but is that correct? Are the lines actually parallel? So what I'm going to do is I'm going to do a check. So I'm going to do a check. And what I'm going to do is I'm going to sub the number back in. I solved for C. Now I'm going to see if that is correct. So I'm going to take C over 7. I am going to put in the 42 that I got. And is 42 divided by 7, does that get me 6? Yes, it does. And therefore, that is a parallel line. So the answer, technically, is C equals 42. Okay? That's what they wanted you to know. They said, find C, so that these lines are, the slopes are parallel. And then we just went and double checked and go, well, that doesn't make sense. The slope is 6. My answer is 42. I don't understand that. So when you put it back in, then we end up getting 6 once we simplify. And then it works. Okay? How did that go? Okay with that? So then what we're going to do is I'm going to show you how to do the exact same thing with perpendicular, and it's the same process, except you have to remember that with perpendicular lines, it's opposite sign and flipped. Okay? Yes. Okay. And then I'm going to get you guys to do a couple questions. So this one. So these are going to be, this is perpendicular lines. So make sure you're making that note, noting that in your notes. So the slope of the first one is -5. I'm going to put it in brackets just so you guys can see that it is negative. The slope of the second line is negative A. Nope, it's not negative A. It's -2 over A. And I'm not going to make it A, I'm going to make it C. So we're going to do the exact same thing, but what we're going to do is, we know that because it's perpendicular lines, the slope is opposite signed and flipped. And if you remember what we just did, when they were parallel lines, we were able to say they are equal. Because if this is a slope of 6, this side has to be a slope of 6 for them to be parallel. So what we want to do with this one is we're going to try to do the exact same thing. So what I'm going to do is take this slope, because right now they're saying they're perpendicular, okay? I want to now make them parallel. I'm going to make it parallel. So I can then make them equal to each other and try to solve it as easily as I just did, okay? So if I took -5, what would that be if it was, if I took it and didn't make it, I don't know how to word this properly without giving you the answer. I'm trying to make it so it's not giving you the answer. I'm going to take it back from being perpendicular and make it parallel. So what I'm going to do is get rid of the negative sign. So I'm going to make it positive. And then I'm going to take it and flip it and make it 1 over 5. So what I just did was said, oh, these lines, these guys, they're perpendicular. I'm going to change one of them. I'm going to change it and make it parallel so then I can do a comparison between the two of them. Hopefully that makes sense, what I just did there. Because it's hard to compare, and it's hard to solve for C if I can't do that comparison with that equal sign. I can't make them equal if they're perpendicular lines. So it's going to be so hard to solve for that C. So what I'm going to do is make them parallel and make them equal. So how I did that was just, all I did was took this guy and unparalleled it, or unperpendiculared it. So I just took away the negative and flipped it, and now these two lines should be parallel because that's what I did. So I'm going to go over here, and so it's going to be 1 over 5 is equal to negative 2 over c. I can put an equal sign now because I changed it from perpendicular to parallel. I'm going to show you guys a fun little tricky thing here. Probably you might have seen this in previous maths. And I sort of showed you with the trig law. Actually, I did. I showed you how to do this with one aspect of it. I'm going to show you the other. If you do something called cross multiply, you actually can solve this a little bit quicker than doing it the long way. So if I do this, I get 1 times c is 1c. And if I go 5 times negative 2, I get negative 10. So all I did was answer that. The other way of doing it is the long way. So what I would have had to have done is, I'll show you the long way right here. Let's do this. If I did the long way, I'm going to put this here, long way. And this is called cross multiply. That's why. I'll give you guys a second to write that in. Okay, so for this, the long way would be to get c by itself, okay? So I'm going to, doesn't matter which one of these you do first. So let's say you don't want to have the 5 on the bottom anymore. You're going to multiply both sides by 5, okay? So this disappears, so I get 1 equal to negative 10 over c. Then I have to get rid of the c on the bottom. I don't like the c on the bottom. So I'm going to multiply both sides by c, and I get c equals negative 10. That's the long way. It's not overly long, but it just involves you having to move things over a couple times in order to get the same answer. This one is called cross multiply. So if you have a fraction on one side of the equal side and a fraction on the other side of the equal sign, then you just cross them and you get your answer that way. So just another little shortcutty technique. If you do the long way, I don't care. That's totally fine if you do it that way. So now it's saying that c equals negative 10. So now what we need to do is double check that this is correct. So I'm going to put the word check. I'm now going to double check this and make sure this makes sense. So negative 2, and it's saying the answer is negative 10. So I'm going to sub in negative 10 down here. Okay? When I simplify this, when I simplify this, the negatives disappear. And 2 and 10, they both have 2's going into them, and I get 1 over 5, which was exactly what I wanted it to be. Okay? So, yes, C is negative 10 for this question. For this section right here, it's negative 10. I don't know how clear that shows up for you when I'm using that color. Let's use that one. Okay, so in order for this slope and this slope to be perpendicular to each other, C has to be negative 10. And that's how we figured it out. So we did it in a little tricky, sneaky way. We said, okay, yeah, let's do this. But the best way for me to do this is to make them equal to each other. So I'm going to change the slope of one of them to parallel, and then I'm able to solve it that way. Okay? All right, so what I'm going to get you guys to do, I'm going to get you to do 2 on your own here. So I'm going to give you, I'll give you guys about 3 minutes. And what I want you to do is there's just 2 questions, and I want you to solve for the missing variable, whatever the missing variable is. Okay? All right. Oh, actually, no. Oh, I'm going to get you to do this one. I'm going to give you guys 1 minute. I'm going to give you 1 minute. I want you guys to do this on your own, and then we're going to do the other one together, just because finding the perpendicular line is a little tricky. So I'll give you guys this one. So these are going to be parallel lines. Solve for C. All right, so line number 1 is C over 4, and line number 2 is negative 15 over 12. Okay, I want you to solve for C. These are parallel lines. Solve for C, and I'll give you guys 1 minute. Okay, so I just started doing some of the work there for you. So you cross multiplied, and then I just need to get rid of this 12. So C equals negative 5. So in order for that line to be parallel with negative 15 over 12, it would have to be negative 5. Okay, and you can check it. So you're like, okay, is this correct? So if I put C over 4 and I put that negative 5 in, it should match the other side. But the problem is, what's the problem with this side? They're not matching right now. What's the problem with that one side? Why are these two not matching? These aren't matching. It's like, no, they're supposed to be parallel. What's the problem? Yeah, I got to reduce this little guy. So I'm going to divide 3. So when I divide by 3, look at that. Look at that. Yes, they do now. Okay. So checking it is always good. That's why I love algebra. You can always sub the number back in and it'll tell you if you're right or wrong, which is really cool. It allows you to get a lot more questions correct that way. Okay. So we're going to do this next. So that's the parallel line one. Hopefully that's pretty basic. The perpendicular one, the only thing that gets tricky with it is that you have to try to change it in order to do this equal sign. Okay, so we're going to do this one together. I am going to just add a page instead of trying to erase. There we go. Okay, so instead of trying to erase, so we're going to do this one now, and this is going to be perpendicular lines. Okay, and we're going to solve for C. So slope number 1 is 1 over C, and slope number 2 is negative 5 over 8. So what is really fun about this one is we're going to be putting a few different kind of our skills together in this one to try to solve this. And that's what makes this one just not necessarily harder, but just a little trickier because you're having to combine some things that you've done before. So I want to make them equal. I want to make them equal. The problem is they're perpendicular, so the slopes are not equal. So what I can do is try to make it equal. So I'm going to change this one, and I'm going to make it into a parallel. I'm going to try to make it parallel with the other one. So all I have to do, just now noticing the line next to the M is a 1, not a comma. Yes. So now if it was a negative 5 over 8, and I want to make it I want to make it into a parallel line, I change the sign. I'm just going to put a little positive there just so you guys know what I'm doing. And then I just take the reciprocal of it. So now it's going to be 8 over 5. So now I can make this equal sign. I can now make those two guys equal, which is super cool because then it makes it easy. So now I just do exactly what I did on the previous example that you guys did. We did a cross multiply. So now I can make them equal. I can now cross multiply. I can easily find out what C is. So I get 5 on this side, and I get 8c on this side. I do a quick division by 8 in order to get rid of that 8 with the c, so the c is by itself, and c is 5 over 8. So that's the answer. You're welcome to go, yep, totally done. But if you want to check to make sure you've done it correctly, you come over here. And this is where we're going to add a little bit more stuff that you guys already know, but now we're going to combine it in. And that's what math does in the higher grades. It makes you work on your problem solving skills and apply things that you've learned in previous lessons, previous years or whatever, and put them all together and see how they all work to solve a problem, okay? So now, c is 5 over 8. I'm going to check this. That was supposed to be a straight line. It went angled. 1 over, okay, I'm putting it in now. And now you guys are going, ew, Miss Meg, that's so gross. There's a fraction underneath the fraction. I don't like it. So what I'm going to do, I know you guys are whining like that. I can actually hear you. Okay, so what I'm going to do now is make this look a little nicer. I'm going to make it a 1, and instead of actually making it with that division sign or actual division fractional form, I'm going to make it so it's just the symbol. And guess what? This looks a little nicer. It looks a little nicer. You have to admit it does. Okay, so now we're like, okay, I can work with this. It looks a little better, but it's still dividing. What do you do when you're dividing with fractions and such? What do you do? What can I do here? What can I do? It's something and something. K and an F. Yeah, kiss and flip, multiply. Yes, good. So what I'm going to do here is I'm going to kiss and flip. So this becomes multiply, and I flip this. And 1 times anything is this. So, look at that. They match. Boom. Done. Okay? So this is the correct answer for C because we just checked it and it matches and we're good to go. So like I said, what you guys did here, we combined some old skills. We did the cross multiply, that's an old skill, and we did the whole kiss and flip, and that's an old skill that you guys had to learn and try to solve this and make sure you're correct. So yeah. So what I'm going to do is I'm going to give you guys till 10:30. I want you guys to spend 90% of that time working on this, okay? This is a practice worksheet that I want you guys to do. And I want you to, we finished basically lesson 3. We did some of it last day and we did some of it today. So I want you guys to combine all of your brain knowledge and put it on the page, okay? So just do a quick 5-minute break, get some water, get a little quick snack, and then I want you spending most of the time doing this. So I've been doing this, giving you guys time, and some of you guys are still struggling to get some work in. So please make sure that you are putting the time into work. This is not a half-an-hour break where you get to go watch TV. This is still a working time, okay? I will be available for chitty chat if you guys need that. And then I'll see you guys at 10:30. Okay, yeah, good. Any questions? Good. Okay, so I'll see you guys in about half an hour. Okay, welcome back. So hopefully you got a lot of stuff done there. I answered a couple questions, so hopefully you guys are doing okay with applying kind of the work that we've been doing last class and a little bit of today. So we are now going to look at a new way of displaying the information. So it's not going to be that I'm going to really teach you anything new. I'm just going to show you a different way of showing the information and what you can get from it. So when we were doing, and it's called slope point form. So what I showed you before, mx plus b, this is the slope intercept form. Okay, so this isn't new. We did this last time, understanding what this does. And remember I said for us to use this to solve, there are 4 things in there we don't know. We have to have 3, and then we can solve for that missing part. Okay. Now we're going to use the other form. We're going to use m equals, and we're going to go y2 minus y1 over x2 minus x1. So we're going to use this formula, and the same thing with this. We can use this if we have, there's 5 things we don't know. Sorry, that's 6. I can't count. There are 5 things we don't know on this one. If we find 4, if we know 4, then we can solve for that 5th one. So what I'm going to show you now is this one takes, it's called slope point form because it gives you the slope and it's going to give you a point on the line. Okay? If you look at the slope intercept form, guess what it gives you? It gives you the slope and it gives you the intercept if you have that information or if you're solving for it or something like that. So eventually you'll have that information. So here's an example. It gives us point. I'm going to show you how this works and how we're going to get to that particular form, the slope point form. So point, I'm going to call it point 1. They give us the coordinates of 1 and 4. Then point 2, they actually don't give it to us. They say we don't know what it is. It's going to be an x, it's going to be y, but they give us the slope of -2. Okay? So they haven't given us everything that we need, but this is the information that I'm going to use to show you how you get to that slope point form. So what we're going to do is we're going to take all of this and we're going to put it together. So they tell us that the slope, so I'm going to use this here. They tell us the slope is -2, so I'm going to put -2 in for m. They tell us one of the points, okay? So how you want to write that down is because it is point 1, the demo I'm going to show you is putting it into the 1 position where that point 1 is. So we don't know what y is. We don't know what that second point is, but we know that the y value of point 1 is 4. And because it's subtract y1, it's subtract 4. Okay, so is everyone okay with that? Does everyone see? Okay, so then this one is now x1, or x2, sorry. We don't know what that second point is. So now what I'm going to do, I'm going to use blue now. I'll just highlight it this way. I'm going to now use the x form for that, and it's going to be -1 because in the original formula it's -x. So we're just going to do one little quick thing here, and we're going to take it and make it into slope point form. So all we're going to do, and this goes back to what I showed you in trig, reminded you about in trig, and what I just reminded you in a previous thing, we want to get rid of this denominator, so all we are going to do is times it by the stuff over there. So we end up getting -2, and we're timesing it by, and you can now start just leaving it as an x because it's the only x that we don't know now, equals y -4. Okay? And what I'm just going to do is just going to flip the stuff so that it looks a little bit more generic of how it's going to be. So it's going to be y -4 is equal to -2x minus 1. Okay? So, let me just get that over there. So this, guys, this is the slope point form. Okay? And the reason why it's called that is 1, that is our slope. Okay? And this is one of our points. So now you're going to be, but Miss Mac, it's not -1 and -4, it's 1 and 4. What you have to remember with this is that this has to be a subtraction sign there. So whatever this number is, and this number is what your coordinate is. So this one would be a 1 and a 4 because it has to be a minus, so it's going with the number that goes with it. That's next to it. So that is why this is called slope point form, because it gives you a slope from it, and it also gives you a point from the line. So if it's written in this form and it says what's the slope, you just look where the -2 is, and if it says what's a point, then you look at the letters or look for the x and the y spot, and then you take the numbers from there. Okay? So I'm just going to rewrite on the next one here. I'm going to show you what the generic form is. So this one right now has numbers in it. So what I'm going to do is show you what it will be when it's generic. So when it's generic, it's y minus y1. So it could be y2 if you want, but normally you'll have that number equals m, and might as well just do that, just so you guys know we're consistent, minus x1. Okay, so this is the slope point form generic formula without any numbers put in. What I just did for you is showed you how the numbers can work and get into that equation and how you can use that to solve things. Okay? So I just gave you a little bit of background information. The main thing is just know this formula, this particular form. Okay, it's not a formula, but it's a form of how to use for plotting things on the line and solving problems. So we're going to do an example together. So I'm going to give you the slope, which is 2/3, and there's a point, which is 3 and -7. Okay, so just jot that down. And what I want you to do, actually we'll do this together, what we're going to do is we're going to put it into that slope point form. So I'm going to rewrite it. You're probably not, I'm just doing this to make it easier for you, you're most likely not going to see that 2 there when you see it in like other math questions or worksheets or anything like that. It'll probably just say y minus y1 and x minus x1. So they just do a little easier. So what I'm going to do is put in the 2/3 in for the slope, which I know is m. So now I just sub that in. And then what I'm going to do is I'm going to put in for the first value. So this is going to stay x, and this is going to stay y. And I'm going to put in, and notice I'm putting the subtractions in because that is part of the formula. What I'm now going to sub in are the numbers. The first point is going to be going with the x, and that is a +3. So I'm putting a 3 in there, and I'm going to close that off. Then I'm going to take the y value, which is -7, and I'm going to put -7 in here. So that is how you put it in, but there's only one thing that we have to fix. They don't want it seeing like a subtract -7. We don't write things like that. What do we do when it says subtract -7? What do we end up changing that into? How would we make this part? I'm just going to highlight it so you know what I'm talking about. We don't write it like that. What do we end up doing? Exactly. Subtracting a negative is the same as adding or plus or positive or whatever you want to put. So you would write it y plus 7 equals 2/3 x minus 3. Okay? So that is how that would be written. And using that information, you can use find the slope from it. You can use that form, and you can find a point. So remember how I was saying that it has to be in the subtraction form. So when I'm looking at this, I have to remember it's supposed to be a subtraction. And if it's not a subtraction, that means the number that was added in, that point that was added in, was a negative. So the points are going to be 3 and -7. Okay, good. Okay? So what I'm going to do is I'm going to give you guys, I'm going to give you like 20 seconds, something like that. It's going to be really quick. What I want you to do is I'm just going to show you guys an example of a slope point form, and I want you right below it to just write down what the slope is and tell me the point that they've given you, okay? All right, so do that about 30 seconds. Go ahead, guys. 20 seconds. Okay, so on this one, the easy part, that's the slope. So you would write m equals -3/8. Okay, now what I put in red, remember that it has to be negatives, right? And if the numbers aren't negative, so when I look at the x, that's not a -3 or subtract 3. So what that means is the point has to be -3, because subtracting a -3 got us that positive, and that's what we just saw in that last example. And then when I look at this one, I have the same situation, because it's supposed to be negative or subtract something. Then because it's now positive, that means the number had to have been this. Okay, so this would be your answer to this question of finding out what is the slope when we look at that and what is the point. Okay, so is everyone okay? Any question about that? Anyone confused why that would have been? So I'll just show you. So this guy is technically saying y subtract -5. That's basically what that was saying, and then we simplified it. So all we had to do was turn it back into that form to see that the number that was put in, the point that was put in for y was -5, and then -3 for the x. Cuckoo. Okay. So now what we're going to do is use this information to now draw on a graph. Okay. So I'm going to give you an equation. You'll need a graph with you, and we're going to use the slope point form. So I have y minus 2 equals -4/3 x plus 7. Okay? So we're going to use this to decide how to draw. So the very important thing is we need to, one, know where to start our points. So sometimes you're given the x-intercept, sometimes you're given the y-intercept, sometimes you can sub in numbers and do a table of values. And then once you figure out the point, then you need to know the slope to see how you actually have to move. So this guy gives you the two things that we need. So this is a 2, and this is a -7. So one of the points that they gave us is -7 and 2. So what I need to do is plot that onto the graph. So -7 takes me over here, and I need to go to +2. So that is one of the coordinates, one of the ordered pairs that they gave us for this question. So now what I need to finish is now draw some more points on the line. And try to do 2 more points. Like, try to have your line having 2 or 3 points on it. It's just nice, unless they say just use intercept form. So now this is the key. This is my slope. -4/3, that is my slope. So that is telling me how to do my line. So from this dot, I'm going to go down -4 and +3. You could have done it the other way as well. Up +4 and to the left -3, it's still going to be fine. So I go 1, 2, 3, 4, 1, 2, 3, put my dot there. I'm going to do another one. 1, 2, 3, 4, 1, 2, 3. All I have to remember is because of this negative, my line has a negative slope, which means it keeps going down to the negative stuff. And if I wanted to, I can add one going this way, and I can see how my line's forming. So So I just have to make sure it's consistent. If I did 1, 2, 3, 4, 1, 2, 3 and put my dot here, I know I'm wrong because it's not in that straight line form. I plotted it wrong. That should be your first clue. So it's not going to be that one. So it's going to be 1, 2, 3, 4, 1, 2, 3. And guess what? It is on my line. I draw a straight line through it, going past the points and putting my arrows on. So if it doesn't plot on the straight line, then you know you did something wrong with your plotting ability. Okay. So what I'm going to give you next is I'm going to give you basically the same thing. I'm going to give you a slope point form kind of equation, and I want you to draw on the graph what the line would look like when you try to find the slope and also looking at the point that's on there. Okay, so am I good to switch off of here? Anyone need it up for a few seconds? Going once, going twice. Okay, so this is what I want you guys to do. I want you to see, it says y plus 1 equals 6 over 5, and in brackets x plus 4. What I want you to do is plot a point on the graph, so you have to figure out what the point is, and then using the slope, plot 2 or 3 more and then draw a line. Okay, so I'll give you guys 1 minute to do that. Okay, so this, I have to remember, it's supposed to be subtraction there, which means if it is in a positive form, that means the number had to be negative. So my x value is actually -4, and my y value is actually -1, and this is my slope. So if I go and plot this, I get to -4 and -1, and I go up 6, 1, 2, 3, 4, 5, 6, over 5. I can go this direction, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, and draw my line going through with arrows. So it should be going up in the positive direction there, and you should have it crossing the y-intercept at 0 and 5. So that's the y-intercept right there. And then roughly somewhere over by 1, 2, 3, somewhere around there it should be crossing, but okay. All right, so that's the slope point form. So you've learned the formula for how to find slope, m equals y2 minus 1 over x2 minus x1. You guys learned that. You learned the slope-intercept form, y equals mx plus b, and you've learned the slope point form. So I've kept referring to another one. I've been saying it, and I haven't actually showed you it yet. There's one that's called general form, and and you've actually had them on your sheet already, which is really cool. So like we don't have to like go into too much detail, but this is what general form looks like. Okay, so basically it has to equal 0. And everything else is on the other side. That's general form. You have the x in the front, you have the y, then you have the constant. This is called a constant, which we've talked about before, that kind of stuff. So that's general form. So I have mentioned it before. I'm like, this is in general form. You need to change it into slope-intercept form or whatever I've been asking you to do. Okay. So what I'm going to get you to do is, I'm just going to remind you how to do this, and then I'm going to get you guys to do 2 questions. So we're going to take, one that's in slope-intercept form, and what we're going to do is change it into general form. So we've taken it already from general to slope-intercept, so I'm not going to worry about that. We've done that a few times, but now we're just going to go the opposite way. So we have y equals 5 over 7x plus 2, okay? So remember how I mentioned that we don't like the fractions, and if you can do something to get rid of the fraction, that's good, because if you look here, we're going to try to avoid having fractions in the general format, okay? So it needs to usually be whole numbers. So what I'm going to do to this, well, actually you tell me, what do I need to do to this so that I have no more fractions in this? What do I need to do to this entire thing so that I can get rid of that fraction? What do I need to do? And I definitely know we've done a couple examples like this before. So what do I need to do? Guesses are good. Trying and making mistakes is better. What do I need to do for this? I'm not giving you the answer. Man, that's loud. Yeah, what am I multiplying by, Jess? Because I want to get rid of that 7. So what am I going to multiply everything by? Well, I want to get rid of the 7. So what do you think I'm going to multiply? The 7's on the bottom, which means division or denominator. What am I going to multiply by? Yeah, I'm going to multiply by the 7. So this is what I'm going to do. I'm going to put some big brackets here and basically show that I'm taking everything and multiplying it by 7. If that works for you, fine. If it doesn't, what you can do is just put a 7, actually I won't put it there, put a 7 and multiply it next to each number. If you need to see it literally multiplying to each one, that's good. You can do it that way, or you can kind of remember the FOIL technique if that works for you. So whatever way it works is fine. So I have to go 7 times y, I get 7y. The reason why we're multiplying by 7 is to make this guy disappear. So if I have 7 as a denominator and I'm multiplying by 7 in the numerator, it gets 1. So that just becomes 5x because it disappears. And then I have to go 7 times 2, which is 14. So what is really awesome now is that we don't have any fractions. Now we can just make sure that we get everything to one side. The x is in front. The x is in front. And then we have the y, and then we have the constant, and then we have equals 0. So it's up to you which one you chose to do. So I just showed you 2 different ways here. You can go times 7 and put it next to each one like that, just to make sure you're doing it correctly, or you can just do it the other way that I just showed you, okay? So then all I have to do now is get everything onto one side. Easiest thing to do is try to get that 7y over to the other side. So it's positive 7y, so I'm just going to minus 7y onto both sides, like so. When I do that, the whole point was to make that disappear, and now I have nothing left on this side. I have a big goose egg, so that's now gone. And then what I'm left with is 5x. I'm going to try to put it back into that form, minus 7y plus 14. And it's fine that way. If you want to rewrite it so that the 0 is on the other side, that's fine. So those are the exact same. Either one of those is fine that you can do. So that is just, and like I said, we've done the general form and we've changed it into slope-intercept. So we've done some of those examples already. So this is just showing you how to take it from slope-intercept form and making it so that it is now in general form. So it's just using previous skills that you've learned, trying to get rid of a fraction. You've learned that previously. and then just doing algebraic stuff, moving things back and forth, which you guys know how to do. So this was just, like I said, taking all those skills and making them useful and putting them together to get something to work for us. All right, so any questions on how to change it from slope-intercept to general? Just the procedure, what we did there. So you can, like I said, you can choose whichever way you want to do it. You can do it where the 7's on the outside and you just kind of do that foil technique sort of thing. Or you can do it where the 7 is next to each thing to make it work for you. Okay? All right, so I'm going to get you guys to do this one. Please convert this guy into general form. So I'll give you guys 1 minute to do that. Okay, go ahead. These are the two I want you to do. I had it in the other one. So A, that was the question we already did. So A is in slope-intercept form, put into general. This one is in slope point form. So you just do the same thing. You guys have the skills to do this. So I'm going to give you guys 2 minutes now to do this. So you guys have the skill to do B. It just looks different, but you know what the things that you need to do. You guys have that in your brain. You're just going to have to give it a few seconds to try to solve that, okay? Okay. Okay, so hopefully that was enough time for you. If not, you can just kind of continue on from where we are. So this one is just exactly what we just did here. And so again, we don't want that fraction. So what I'm going to do to this entire thing is times it by 2. All right? So I need to times every part of it by 2. And the whole point, the reason we're doing that is to make this guy no longer be a fraction. So I'm going to go y times the 2, so I get 2y. And the reason, like I said, why we're multiplying is because this denominator is a 2. This goes into the numerator spot, which means they cancel out, right? And so I'm left with just negative 3x. And then I have to times this 2 by negative 5, and I get negative 10. So yay, we have no denominators anymore. So now I just have to get it looking into the general form. So in this case, what I have to do here is subtract the 2y, subtract the 2y. Whole point of that is to make that disappear. I'm left with 0, so it's negative 3x minus 2y subtract 10. Okay? And what we can do, which is going to be super cool, is if we now switch everything to the other side, we're actually going to be changing the sign. So all I'm going to do, just watch what I'm going to do here. I don't like that there's so many negatives in it, and so if we move things back and forth, we actually can change that. So if I add, oh actually, sorry, wrong color. If I add 3x here, I'm going to add 3x onto this side. If I add 2y to this side, I'm going to make it disappear on this one side. I'm going to add 2y on this side. And if I add 10 on this side, I'm going to add 10 on this side. Watch what happens. So now I have 3x plus 2y plus 10, and now the 0 is on this side. So what I did by actually taking those numbers and physically moving them over, I have made them now all positive. So you're probably going to see this happen. So like, for example, if I give you a multiple choice question and if you don't see it, if you don't see this one, but you see a whole bunch of ones with these numbers, but they're all positive, it's probably going to be that they just individually moved them over and made them more positive. Okay? So how many of you guys at least got to this spot? How many of you guys at least got to that spot? Just with a check mark, how many of you guys got that? Couple of you? Okay. So hopefully the people that didn't get there, does anyone have a question about it? If they still don't see how we got to that point at least. Does anyone have, want me to show them something else or anything? Okay. All right. Your job to ask questions of me. Okay. So this one, again, I actually have two options here. So I'm going to, does everyone have this written down? Because I'm going to erase it because I'm going to split and do two. How long does it take to post a lesson just so I can? It could be, it depends on how long it takes YouTube to post it up, and then I have to go and get it and post it in. So it depends. I can't give you a whole answer, sorry. Does everyone have this written? Because I'm going to erase this because I'm going to do this question in two different ways. Okay, I'm erasing. All right, so what we're going to do here is I'm going to show you two ways of doing it. It gets you the same answer, and it all depends on which one you want to do. So this one, what I'm going to do over on this side, just to try to simplify this, what I'm going to do is first off, multiply that negative 1/3 by everything in the brackets, okay? So I'm going to keep this the same, and what I'm going to do is go negative 1/3 times x, which is equal to negative 1/3 times x, okay? Then I'm going to multiply, which is like the FOIL technique. This is not technically FOIL, but sort of the same idea. Negative 3 times, negative 1/3 times negative 6, okay? Now, when we simplify that, this stays the same, and this turns into, where do I write this? I'm going to take this part right here and I'm going to move it over here, just so you guys can see. What that does is, just like I've shown you many times before, this is like two fractions multiplying together, because negative 6 is in a numerator spot, which means the denominator is 1 if it's a whole number. So negative times a negative is a positive, so I have 6/3 when you multiply fractions together. So my answer is 2. So I'm going to put, and it's positive, so I'm going to change that to a 2. So then from this stage, what I would do is now multiply everything by 3 to get rid of that 3. Okay, so I would take everything over on both sides and multiply by 3 and continue there. So all I wanted to show you was it is possible to take that negative 1/3 and multiply it and simplify it that way. That's totally possible. The other way you can do it is right away, right now, multiply everything by the 3 to get that number to disappear. Okay? So that's what I'm going to do here. So I'm going to take the 3 and multiply it to the y. I get 3y. I'm going to take the 3 and multiply by the 4, I get 12. Okay, hopefully everyone's with me. Tell me if you're confused as you start going, let me know. And remember, the whole point of doing this is because I want to get rid of this negative, or get rid of this 3. So by multiplying by the 3, it disappears. So this becomes just negative 1. And then I'm left with this. Okay, so what I did was times it by 3. Now I don't times, I do not, what I'm going to show you in blue is I don't do these two because this is multiplying to it. So as soon as I do this, it disappears. It's not there. Okay? How did you get rid of the 1 over 3 next to the negative 6? I showed it right over here. So this is what I did in red. That's what I did right there. I showed you that whole process there. Okay? All right. So now that we have this, now we can start simplifying this a little bit more. So the 3y plus 12 stays the same. Now I just need to combine these guys. So negative 1 times x is negative x. Negative 1 times negative 6 is positive 6. And now I just have to start moving things around algebraically to try and get my answer to look in the general form. Okay? So I'm going to move the x over to that side. So I'm going to add x onto this side. So when I do that, I get x plus 3y plus 12, and I still have the 6 onto this side. If you're able to do everything in one shot, go for it. So if you can see that you have to move the x and the 6 all at the same time, you totally can. So it's up to you, but if you want to do it in 2 different steps, you can. Okay, so now I just have to get rid of the 6, so I'm going to subtract 6 on this side, subtract 6 on this side. So I'm left with x plus 3y. I have a 12 minus a 6, which means plus 6, and I'm left with a 0. And here is this form. Okay, so I split that question into 2 so you could see that you can get to the final answer the same way, but it's up to you what you want to do. So for example, like I find it easier just to get rid of the 3 right away. Then I don't have to worry about fractions being in a whole bunch of different spots. Some of you might like the idea of just dealing with the fraction and then getting to it, having it disappear after that. Okay? Give you guys a few seconds. So again, there's really nothing new here. It's just taking old skills and just putting them into a problem for you. All right? Okay. So we have now learned 3 forms of how to write these numbers, and each one of them is good and useful in certain situations, and each one of them allows you to interpret a graph and put it into the formula, into like the forms, or take what the numbers and the information that's in the forms and then create a graph. So they all allow you to go back and forth. So we're just going to do a little reminder of what the forms are. Okay, so we have the one that's called the slope-intercept form. Okay, actually no, I'm not going to put equal sign, which is y equals mx plus b. You have also learned the slope point form. Okay. That is y minus, so you can do y2 minus y1 if you want, equals m and x2 minus x1. And then what we just learned was the general form, but we've talked about it a few times. And in the general form, you're going to have, this is how it kind of looks. This is the generic one. So in the generic one, there's no numbers. So it's going to be whatever that big number is in front of the x, and then whatever that big number is in front of the y, and the constant equals 0. So those letters are just representing a number we don't know. It's just another variable. Normally, like in the previous example, we had numbers in those spots. So that's just all what that means with that. And in order, the whole point of doing this is to be able to either take stuff from the graph and put it into these forms, or take what information is in these forms and put them onto the graph. So everything that you need comes from these forms. So one thing that we need to have the slope. We have to get the slope either from the graph, or we have to be able to see the slope from this form. We need to do that. So in order to draw anything, we need to know what the slope is, or else we can't draw the line properly. And we need to have at least one point on the line in order to do that, because we need to have a starting point. We need to have a point to start and then figure out how we move from there. If we are missing one of those two things, we won't be able to do it. Or we have to do something else to try to get those pieces of information. This is just a reminder, okay? This is just a reminder. In your notes, you already wrote down the slope-intercept formula and the form for point slope and the general form, okay? And then just a reminder again, what are the things that you need to have, which you know, because in order to draw those, you need those things, okay? All right. So here we have 2 points on the line, okay? And what we're going to use, we're going to take those points on the line and try to create the slope form formula for this, okay? So the slope form formula is y2 minus y1 equals m, and the x2 minus the x1. So that's the form we're going to start using. And what we're going to do is put in the information that we can get off of this graph, okay? So, slope. In order to have the slope, we have to be able to count from the graph. So what I've done for you is I've given you, I actually wrote the numbers in so it's easy to see. So it's basically, and it's a negative slope. If you guys notice, it's going down this direction. Because of that, that means it's a negative slope. So my slope is going to have a negative in it. So it's going to go 1, 2, 3, sorry, 1, 2, 3. So it's going to be negative, and it's going to be 3, and then it goes 1, 2, 3, 4, 5. Okay? So my slope is negative 3 over 5. Now the only other thing, so like I just said in that previous part that we wrote, we need two things. We need the slope and we need a point on the line. And a lot of times what's easiest to use is numbers that have like ones in it and zeros in it. That's usually what you try to pick, but you can pick any number on the line. And we're going to sub that in. So that goes, so this is going to go subtract 1 right there, and that's going to go subtract 1 there. And then all I do is sub in the other stuff. So what we did there is just interpreted the graph, took some information from it, and then plotted it and put it into the slope point form of that. So what I want you to do, we're going to use this equation. What I want you to do is I'm going to give you guys 2 minutes, a minute each question. Just down 3 over 5. Yeah, exactly. What I want you guys to do is a minute a question. I'm going to want you to change this guy into, what am I asking you to change it to? Slope intercept form, and then I want you to change that into general form. So we're going to get a little bit more practicing of moving things around and just using our algebra skills. Okay, can I change this over? Does anyone need this on longer? Okay. This is the last 2 minutes, and then we're going to, I'm going to leave you. 1 second, okay. You still have me on? A student just said 1 second, so yeah, no, it's okay. You're good now? Okay, perfect. So here are the question I want you to do. So I just rewrote it here. I want you to change it into slope intercept form and I want you to change it into general form. So a minute to change it into slope-intercept and a minute to change it into general. Okay, so I'll see you guys in 2 minutes. Okay. Now. Okay, hopefully that was good. So what I just started doing was showing you, like I showed you that one question I split into two. What I did here was, these are exact same questions, and I did one way and I'm doing one the other way. So just so if some of you are doing it certain ways, you at least get to see it done the way you're doing it, so you can make sure you're doing it correctly and see if you're having any difficulties. So what I did with this one here, I'm going to turn this one into slope-intercept. I'm going to do this one in general. So this one, what I did was I basically took the -3/5 and times it by everything in the brackets, and that's what got me to this stage. So now I want to get rid of those 5s. So now what I'm going to do is multiply every single thing by 5. Okay? So when I do that, I get 5y minus 5. I multiply there, so those 5s cancel each other out. So I'm left with -3x. And then those 5s cancel each other out. That's why I'm doing this. And I get 3. So now I have no more fractions, which is a good thing. Okay? So then all I need to do is I'm doing y equals mx plus b. So I need the y on the one side and everything else on the other. So I got to get rid of this 5 here. Okay? So when I do that, the whole point is to make that guy disappear. So I'm left with 5y over here. I'm left with -3x. And now I have a +3 and a +5. So I get +8, +8. And then still one little small problem. I have to now divide by 5 to do this. And you get y equals -3/5x plus 8/5. Okay? So that will be the answer to that one. So that would be that converted into slope intercept form. So y equals mx plus b. Okay. Check marks if you got it or now get it and are like, where are we at? So give me some check marks to see how you guys are doing with converting that. Okay. So if I look at the check marks now, it's showing me that basically most of you guys have no clue what I did here. Is that correct, or are you guys just not participating? I don't know how to read this, so I need to either be participating or ask me some questions if you're not understanding, because I'd say about half of you now. So you can't see it. It's too blurry. That'll be your end. Sorry, Caitlin. Okay. Can you maybe just zoom into just that question if you don't mind, just to see if we can help her, see if it's better for her? Okay, that's a little better, but I'm not forcing you guys to put check marks to move on. I just want to make sure you guys are good. Okay, so hopefully that's a little clearer for you, Caitlin, for you. Okay, all right. Yeah, that's the best we can do. It's probably mostly your end, your resolution or something. Good. Well, that's what we're looking for, Caitlin. We want you to be able to read it. Yes. Okay. So this one now, all I did here was now just get rid of the fraction right away, multiplied everything by 5. So I went 5 times the y, I got 5y. I did 5 times -1, I got -5. And when I times 5 by this part here, it gets rid of that fraction, okay? Okay, yeah, that's fine. So as long as you can kind of see what I'm doing, and practice will make it come a little quicker and make it easier to understand. So, okay. All right, so now that I'm at this form, all I have to do now is I need to change this. So this stays the same, and I just need to simplify. Yeah, perfect, good guys, okay. So now what I need to do is just simplify this. So I get -3x and I get +3. And the general form wants everything on one side. So I'm going to move this one over, and I'm going to show you, remember I said some of you guys can do this in one shot. So I'm going to add 3x onto this side and add 3x onto this side. And if you're wild and crazy, move this guy at the same time. Oh my goodness, Miss Mac, what did you just do? Okay, so all I am, instead of doing that in 2 separate steps, I'm going to do it all at the same time because I know how to move it, right? If you did it in 1 step, I don't care. It doesn't, or 2 steps, doesn't matter. So now I'm going to go 3x plus 5y. So there's my 3x. There's my 5y. And now all I have to do is combine these two together. So I have -5 and a -3, which gets me -8. And on this side, everything disappeared. Boom, boom. And there's that form, okay? So there is the general form, and there is the slope-intercept form for that. All right? Yeah. Yep, for the general form, everything just needs to go on the other side. You're just trying to make it easier to work with. You could have moved it over there at the first step, but it's so complicated with the 5 and the denominator. So you just try to get rid of that, make it so it's nicer to look at, so you're not like, ew, I don't like this. Yeah, okay? So we're going to end there. All you guys have is, I'm just going to have one thing for next class. So you guys had the practice worksheet. Hopefully you guys are working at that and understanding. No one had any questions for me there. And then you just have one to hand in, okay? And that's just working on what we've been working. This is lesson 3, so there'll be some stuff from last lesson, which is good, and then a little bit from today. Basically stuff from before break and then from last class will kind of be this stuff. Okay? All right, now, some of you guys last day, and I even have proof, Magical Merle heard me say this, you guys need to start getting your work in. And some of you guys, when I said give me the work and catch up and let's get going, some of you guys still didn't get any more work done. And that was from Wednesday. So that's, you still should have been working on Wednesday. Like, we're done today. You guys should be putting another 3 hours of math time in today. Like, you really should be. You're putting in 5-hour days. So even when our lessons are done, you need to continue working. And then you had Thursday, you had Friday, you had Saturday, you had Sunday. So I know there's some circumstances for a couple of you, but some of you guys now are now pushing, we're finishing this 3rd unit since our report cards and stuff came out. So some of you guys are now becoming very far behind. So we got to start plugging away and getting that work in, okay? So this week now is the test from this previous unit that we did on relations and functions. So that's like domain and range and all that kind of stuff. So here you have, again, just some reminders. I know. So Alexis, unfortunately, you're going to have to find the times to do this. So if other things are happening, you're going to have to figure it out. So like, for example, I had to do report cards this weekend. I was busy all weekend. I had to find the time, right? So that's just part of being grade 10 and getting mature, right? So just some reminders, make sure work is all done for this relations function unit. So is that previous stuff we've been doing. You need to do it from today till Friday. Okay, so get that done. Remember, have some confidence, look over the stuff, redo questions, have someone give you a question, send me messages and say, I'm not sure about this. Have that positive attitude going in because it does really, really have an effect on things. And announcement. Wednesday, I'm going to give you guys as much notice as possible, and if you can't make it, that's fine. We're still going to, we'll still send it out live. But Wednesday, December 20th, I would love to have you guys come here to McWilliams Center from 9 till 10:30. And you need to bring calculator, pencil, and paper, and we're going to do kind of an activity for about an hour and a half. So we're going to have a little bit, it's not a test, it's not a quiz, it's nothing like that. We're going to come in here and we're going to just do a little bit of fun stuff that has to do with one of the units that we're going to be doing coming up. So note, because the lecture will be this. So people who can't make it, you're going to be brought in by Zoom. So you're going to be part of the class. So it's still happening, but it's not like we're going to be doing what we do like today. So we're going to be doing activities, and there's still technically a class, but it's not going to be where I'm actually teaching stuff. We're going to do stuff. Nope, Friday is the 22nd. That's the last day. So Wednesday, there's still classes all that week. Okay, so mark that down. Try to figure out a way of getting here. I expect some plane tickets to be bought. No, I'm just kidding. And so yeah. And you guys have a quiz just to see where you're doing, not today's lesson obviously, but the stuff previous to that, just looking at where you are in your journey of learning. Yes, everyone's on a journey, see where you're at. Yes, you'll be on, well, I would like you to be here, Jess. So, oh no, you're not even here. Yeah, so sign into both of them, because then you can ask me questions in Blackboard while we're doing all of our stuff. Okay? Yeah, get those tickets, come on. So yeah, so here's what you got to do. All owed work needs to be done for relation and functions so that you guys can take the test this week. One worksheet is practice and one is due Wednesday, and you guys have a quiz to take for me. Okay? Just so I can see how you're doing, and that's on basically slope intercept form. That's basically what the quiz is on, with a little bit of applying what you know. Okay. So what I expect you guys to do is go take that quiz, get that done, and then put a few more hours in, get the worksheet done, start studying, do what you need to do, and make sure you're ready to take that test this week. Some of you guys are behind a couple now. Okay, so got to bear down. You might have to be putting a lot of math time in today, which is good, which is good. It's exciting. It's exciting to do all the math. Okay, so any questions? I'll post it up. Yeah. I'm going to post it up. It'll be on Moodle. Let's say it on Moodle. Okay. Actually, let's do that right now, shall we? So you guys can see that I'm not lying to you. La, la, la. Where is it? Da, 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 da. I'm in the wrong unit. Blah, blah, blah. Da, 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 da. Actually, I already did. It's already there. See? I'm like way ahead of myself. It's Hercules. All right. So if we are good to go, I will say goodbye, and I'll see you on Wednesday. And again, bombard me with work, get those quizzes done. Have a good one, guys. Bye. See you, Dean. See you, Jess.